In this section, what we need to be able to do is still find probabilities based off of normal distributions, which means we're still going to be using the Normalcdf function. But the thing is, with the central limit theorem involved, what we need to take into consideration is the effect of the standard deviation when you include the average of a sample. So what we'll do is, like I said, still use Normalcdf, and that's still found if you hit second and the vars key under the distributions menu. Now, it can take up to 4 inputs, and so when we use this, the inputs that we're going to provide would be a lower bound of a shaded region, an upper bound of a shaded region. Those are always the first 2 inputs. But then we'll do a mean and then a standard deviation. But we can go ahead and do this standard deviation like in line in the calculator. And go ahead and write it, and it will show up as like our standard deviation divided by the square root of n. It'll look a little bit more strange in the notation of the calculator with parentheses and everything, but that's effectively what we'll do. So for instance, here's an example question. The average speed of drivers on a certain stretch of the German Autobahn is 142 kilometers per hour, with a standard deviation of 22 kilometers per hour. What is the probability that the average of 40 randomly selected drivers on this stretch is more than 150 kilometers per hour? Well, to do this, the first thing we need to notice is that we're on a normally distributed set of data. And it's not really explicitly stated here, but because we're using the average of 40 randomly selected items, the central limit theorem tells us that that's a large enough sample, it just needs to be bigger than 30, that we can assume that we're working off of a normal distribution. So you can draw a bell-shaped curve. The mean in this case is 142. The standard deviation is given as 22, but then that's going to be reduced by a factor of the square root of that sample size of 40. So here's my mean of 142, and now the question is asking, what is the probability, I meant that to be a highlighter, what is the probability of the average of 40 randomly selected drivers on this stretch is more than 150 kilometers per hour? So 150 kilometers per hour might be right here, just a little bit above 142. And if we want drivers that are driving more than that, we would shade to the right, because those would be speeds greater than 150. And so my shaded region, the lower bound here is the 150. The upper bound is technically positive infinity, but of course when we push that into the calculator, we're going to use e to the 99th power instead. And then my mean is, of course, 142, and then the standard deviation will be this part right here. So those will be the inputs that we provide. And let's see what happens. So the lower bound is 150. The upper bound is second and comma, which gives me the small capital E, which means scientific notation, so e to the 99th power is a very large number. And then the standard deviation, mu, is 142. Excuse me, the mean, mu, is 142. And the standard deviation is going to be the original standard deviation of 22 divided by the square root of 40. And it's perfectly okay to put that as an input to this function, because the calculator will evaluate that first and then use the number as input to Normalcdf. And that's all we need to do. That will give us the final answer of the probability here.